Hi, everybody. Today we are at Buckeye Furnace in Jackson County, Ohio. And this is a historical charcoal iron processing furnace. And for those that are familiar, or maybe even for those that aren't familiar, this stone structure that we see at the bottom is what we often associate with early iron furnaces, because that's what remains. And we see these in Laurel and Greenup County, and we see them at Greenbow, Buffalo Furnace, Vesuvius in Lawrence County, Ohio. So this is often all that remains is this stone structure. But here at Buckeye Furnace, we have all the accompanying buildings that have either been preserved or recreated, and we'll take you for a tour on this site. So the first part that we're going to walk into is the casting house, and we have the furnace here. We have the charging ramp and charging house, or the bridge house. And then further up the hillside, we have like a storage shed structure for processing the iron ore, getting it down from raw ore to workable material, as well as the charcoal pits and charcoal storage areas. But since we're down here, we'll start with the casting house. So the Ohio History Connection, I believe, has provided a lot of interpretive signs that help understand what we're looking at. But before we go to our first sign, I want to walk you up to the opening of this furnace. And the opening has to be at least 10 foot wide, and for conservation purposes and for safety reasons, you can see it's gated. Laurel furnace, you can actually go all the way up on the inside of it. Don't recommend, but it's there. So here we have, I don't know if you'd call it a hearthstone, but it says Buckeye Furnace, T. Price Builder, 1851. So, well, I don't know because I'm not familiar with this. We just picked a spot on a map to go today, and this is where we are. So this is the casting house. We'll pan around here. And let's start with the very first thing, because we know we're going to see about the structure, but what do we know of the people that worked here? Because this wasn't a small operation. This was before the days of automation. It required a lot of manpower and a lot of resources. So very informative sign from the Ohio History Connection. It says, work at an iron furnace, like most 19th century industrial jobs, was low paying, uncertain, and dangerous. Most furnaces operated at the edge of bankruptcy, and because nearly all were small-scale operations, they could not weather the storms of economic depression or financial crisis. The Panic of 1873, for example, so depressed the market for iron that by 1878, production plummeted to 1/8 of the pre-panic output. Some 48,000 tons of unsold iron piled up at Ohio furnaces and stockyards. During these times, workers were laid off. They had no unemployment insurance and had little hope of finding other employment. Most companies attempted to keep their workers on in the furnace operating by cutting wages. The average wage was only $10 per week in good times. When forced to choose between even lower wages or no job whatsoever, workers selected the former. One of the major complaints of furnace laborers was the widespread practice of paying wages in scrip rather than cash. The Hanging Rock furnaces defied state laws and paid their employees most of their wages in paper bills of credit, redeemable only at the company store. It was common for workers to rent company-owned housing. This system tied the workers to the company in a closed economic system. The company regained a large portion of the wages through company store and rental profits. So if you weren't being paid in cash and only paid in money or script that could be spent in the company store, your buying power was often less. If you bought a pound of flour and it cost you $1 in an open market, at the company store, it might be $3. So your buying power wasn't as great. Now, work at the furnace was hard and often dangerous. The 12-hour day was common. Heat stroke, asthma, eye disease, and gassing by the furnace's toxic fumes were job-related dangers workers faced daily. There was seldom any type of health insurance or pension plan and no government aid or regulations. Now, despite these conditions, there was little union activity and few strikes at the Hanging Rock charcoal iron furnaces. One reason for this was that workers who did attempt to organize or strike often found themselves on the blacklist. Now, this was an informal agreement between the furnace owners not to hire troublemakers. So it's not like you could quit your job today or get fired for organizing a union and just go down to the next furnace. These furnace owners, communicated and would say, hey, don't hire this guy. And with that threat hanging over their head, workers often endured difficult working conditions. Now, a more important factor, however, was that the working relationships at the charcoal iron furnaces. Most furnaces were located in isolated areas where the community of about 500 people all worked at the furnace in some capacity. Now, this bred a strong sense of community consciousness. The manager and workers knew each other well, and workers could go to the manager with their problems or complaints. This resulted in informal working agreements that negated the need for formal groups like labor unions. Additionally, companies often allowed workers to stay on rent-free during hard times and attempted to keep the furnaces operating as long as possible. Most workmen preferred a decrease in pay and a roof over their head to unemployment. Now, they also realized that striking during a depression could hasten the company's demise. So even though things are bad, they could be worse. Now, as the charcoal iron era faded in the 1880s, workers were displaced. The depletion of forests needed to fuel charcoal furnaces, and the introduction of new, more efficient coke furnaces transformed the industry. Many charcoal workers moved to the coke furnaces, where they found it necessary to band together into unions to win concessions in a modern industrial environment. Now, we have, these strong communities of 500 people where everyone was really tied to their job and their fates tied to the success of the iron furnace. Talk about, who worked here. Now, your workforce was, you had an iron master who was the overseer of the daily and long-range planning of the furnace operations year-round. So, what is the order? What's the demand for iron? How much can we produce? And often, who got to work today? Skilled axemen employed 48 people in chopping and charring the wood, cutting 2 to 3 cords of wood a day between October and the middle of April, 20 days a month. Colliers, people that we now associate with coal miners, were foremen. Now, they made the charcoal, and we'll see more about that once we go on top of the hill. They prepared the foundation of the hearth. They set the wood, the leafing and the backing of the pit, and charring the wood and drawing of the charcoal. Once it was done burning out, actually drawing the charcoal out. Miners, mining iron ore and limestone. 14 to 21 men engaged in this work all the time. So they mined it, they hauled it, they screened it to remove fines. They hauled the stock to the furnace. They helped smelt the iron ores and hauling the iron to market or a place of shipment, which in this case, it would have been Raccoon Creek. Now, the operation of the furnace, and that's what we'll see most of here today. The general manager is charged with the furnace, timber, and the ore properties, making sure everything for the day's work was needed there. The foundry men for the blower, engineers, chargers, people to load the furnace, a keeper and a helper, casters, people working in the building that we're standing in right now, who casted the iron pigs, sanded it while it was still hot, quenched it with water. A slag loader, we'll see the slag wheel here in a moment. He was essentially a hamster on a wheel. A store clerk that operated the company's store, and an office force. People had to keep track of materials that were owed, bills that had to be paid, employees. And then other skilled laborers, all these buildings here had to be built by someone, your day-to-day operations for taking care of horses. You had to have a blacksmith. You had to have a store, people who gave food out. So that's just an idea of, the labor force that was here. We see 4 or 5 buildings left, but at one time, this would have been a community of, 500 people. So, like I said earlier, we are in the casting building, and we're about right here. And you can see above us, this is the furnace and the loading ramp, or the charging house or the bridge house. And then we have the engine house here. So during the casting process, we're kind of working backwards because it doesn't start here. It generally ends here as far as refining iron ore. But we'll get to that when we go up. During casting, 8 to 12 men were required to perform various jobs. Before, during, and after each cast, 7 basic steps were required. Now, workmen using wooden forms, just like concrete workers today, as a pattern, made a series of molds in the sand floor of the cast house. Each mold was connected through a channel to a main runner that ended near the mouth of the furnace. So if we can imagine, this is the mouth of the furnace, and then we have the channels that ran off, and then we have these small ingots here. Now, we have the furnace hearth, and we have the slag and the molten iron beneath the slag. The slag will be the impurities that have bound with the limestone under high temperature, and it'll be on top of the molten iron. When the furnace hearth filled with molten iron and slag, the air blast was stopped and the process of tapping began. Now, the tapping process began by draining off the slag. This was done by knocking out a clay plug at the top of the dam stone. And this allowed the slag to drain from the furnace and collect in a large puddle on the left side of the work arch. So if we look here, we would have, there's the hearth. And imagine your molten iron being down here, and you would have had your plug up here, and over here you would have had your slag pool. Now, after the slag was tapped, the clay plug called the iron notch at the bottom of the dam stone was removed, and molten iron was allowed to flow into the molds that had been previously made in the cast house floor. Now, while the hot iron was cooling, the pattern formed by the molds and channels on the casting house floor resembled a sow nursing piglets. Because of this resemblance, the iron taken from the molds was referred to as pig iron. Each pig was 4 feet long, 4 inches wide, and 6 inches deep. Now, when the iron had cooled, workmen used sledgehammers to separate each pig from the iron remaining in the connecting channels. The iron was loaded on wagons and carts for shipment to foundries where it was converted into iron products. Now, while the slag was cooling, a heavy chain was attached to it. The other end of the chain was attached to a large slag wheel. We'll see that here in a second. And the entire mass dragged to the front of the casting house. Using sledgehammers, workmen broke the slag into small pieces and loaded it onto wagons and transported the waste material to a refuse area, or it was used on roads. And after the iron was drawn from the furnace, the dam stone was plugged, the air blast turned on, additional iron ore, limestone, charcoal were added again, and the cycle began again. So it was continuously ongoing. Now we talk about the iron pigs. So we have our main channel here, and we have these pigs that come off of it that were 4 feet long, 4 inches wide, and 6 inches deep. So they had to bust all that apart manually. What's neat, and one of the biggest features that we see, is that large slag wheel. We'll pan over here, and we're towards the back of the casting house. Here's the furnace. We can see the engine house here, and this behemoth is the slag wheel. Now, as we walk over to the slag wheel, it's, for safety purposes, has been chained up, but we can see as we step back from the wheel, we have this large axis. So you would have your slag behind us and then a chain attached to it. Now that would be a lot of work if you were just trying to pull, men with a rope or a chain pulling it to the front. So what was done was that chain was fixed here, And then a person would climb onto this wheel, and just like you would climb a ladder, they would climb the rungs. As they would climb the rungs, that chain would wrap around the axis and pull that slag forward. Now, so this is the casting house, the Buckeye furnace. And we're going to walk around here because we mentioned how a blast furnace worked, and we'll get into more of it when we're up in the bridge house. But you had a cold blast and a hot blast. Now, hot blast was more efficient in that it was faster and it used less resources like charcoal. But it was thought that it didn't produce a superior product such as cold blast. So we'll walk up the stairs here. I just want to touch on the amazing stonework that has been done. And a lot of this is just locally quarried limestone because limestone's heavy. It's a great building material, but it's heavy and you don't want to transport it far. So a lot of times these furnaces were located near limestone. And you can see the work that the stonemasons put into just this edge here. Everything else is really roughly cut. But this edge has been finished, which is neat. Other charcoal furnaces, you'll find workers' initials. We found effigies carved into them. It was really neat. We're going to walk up the stairs here. And we can see the side of the furnace. Okay, we'll take a step back. Here's another side of the furnace, and you can see how it's carved into this hillside. And if we look up, we can see the charging house or the bridge house. We can see right there where it feeds into the top of the furnace. And we have this open top roofing structure. And then there's a bell there at the end. We've been talking about what purposes would the bell have been. You know, would they have signaled? You imagine how loud it would have been working here. Was that signal just to go to work and the end of the day? Or could that have been a signalman for the blast furnace to be turned on, for the engine to be cut, more material? Was there a bell system? I'm sure somebody out there has an answer to it, but we're just super excited to see one of these older furnaces, especially if this was built in 1851, to see these accompanying structures still here, because before it was just our imaginations. Now we'll walk over to the engine house. Now we have a nice little placard here that tells us about what kind of engine we have. Now, the conversion of iron ore into molten iron required very high temperatures, and to raise the temperature, compressed air was pumped into a furnace. Similar to what you see blacksmiths using today, they use a bellows to increase the amount of air going in to get those higher temperatures. But this is a much larger scale than a blacksmith. Now, a steam engine located in the building to my right provided the power needed to compress the air pumped into the furnace, and the engine turned a 15-foot flywheel that operated two blowing tubs. Pistons located inside the blowing tubs forced air into a pipe that carried the air to the upper level of the furnace. The air was heated by the hot gases that came from the furnace stack and piped into the furnace through two openings or tires located at each side of the furnace. We have a great diagram here of how that worked. And we're standing right about here. As you can see, above here would have been piping that would have ran into the bridge house or the charging house. And that in turn went to boilers, what we'll see inside of the charging house. And here's a diagram of the engine. But diagrams are great, but let's go see the real thing. We'll pan around here. And if we look up, we can even kind of still see some of the piping there by the supports. So let's walk in. Up the stairs we go. Very large room, but could you imagine the noise that would have been created? And here we have our flywheel. that operated the piston. So sometimes you may have seen something similar to this at your local county fair, where they use them to make ice cream or popcorn. It's still a common design, just on a much smaller scale. And that's really all there is to this structure. I imagine at one point may have been larger. I'm sure they went through different design variations. We'll pan around here again, make our way back out. We come right out the front door here, and we're looking down at the casting house, over to the furnace, and up at the floor of the charging house. And then we'll come down the stairs carefully. And for anyone visiting, these stairs are kind of wobbly. They're not anchored to anything. So I'd only advise you to have one person on the stairs at the time. And we'll pan around here so you can see the foundation that this building sits on. So I'd imagine even it's accessible underneath. There'd have to be a pit for that flywheel. Okay, there we go. The charging house again. The furnace. And now we're back in the casting house. And the casting house floor were, it would have been covered in sand, and the workers would have laid out their wooden forms for their iron pigs. And over here we would have had the slag pool. We'll make our way back out. And get another good shot along the side. We normally walk around behind the furnaces just to look, but look kind of snaky today, so we don't want to risk it. But just a great view of Buckeye Furnace in Jackson County, Ohio. And again, this is a great find for us because we're so familiar with these stone structures. That's all that is left of this, early Ohio history from this charcoal region, from this iron region. Is often these stone structures is all that's left, but here we have all the accompanying buildings that share a little bit more of history with us. So now we'll take off. We're going to walk down the road a little bit and back up the hill, and we'll show you what's up top. Thanks. Okay, and now we're on the back side of the furnace. So here we can see Buckeye Furnace, the charging house, and we kind of pan over here to the right. We can see the stock house. We'll make a trip up and around here, but we're going to stop at the first sign here and kind of just pan over. A lot of these signs were provided by the Ohio Historical Connection. And one of the things that people don't really keep in mind when they think about these older furnaces, these older iron furnaces, was that they were charcoal furnaces, not too dissimilar from our modern coke furnaces that we use, but they were charcoal, so they used a lot of wood to make charcoal. So the picture here is a stockyard shed at Monroe Furnace in Jackson County, about 1865. It closed operation 1877. But large tracts of land were cleared of their trees to create the charcoal that was needed in the process of refining this iron. So we'll kind of start out here at the stockyard and work our way up the hill. So again, a lot of the furnaces that we see today, we just see the stack for it. We don't see the charging house or the ramp, the charging ramp. And we definitely don't see a lot of the other structures that accompanied the furnaces. You know, we just see this small limestone chimney looking thing. There was so much more to it than that. So we'll come to our next interpretive sign that shows the stock shed. And this was again from the Monroe Furnace in Jackson County, and photo was taken about 1870. Now, the stock shed was used primarily as a storage area for charcoal, which was a fuel used to reduce raw iron to a molten state. So, can't really show you how immense this building is, but just the posts that you see there running vertically, I would guess that they're at least 8 by 8. It's a very large building. We'll walk around here to the edge. There's another interpretive sign that's really important to understanding the process. You know, we know that large tracts of land were cleared for the manufacturing of charcoal, and charcoal was used in the refining of iron ore. But how do we go from forest to charcoal? And that's what this interpretive sign helps with understanding. So the iron making process required 3 basic ingredients: iron ore, charcoal, and limestone. So when mixed in proper amounts and subjected to intense heat in the furnace, these ingredients combine to produce molten iron and a waste material called slag. And around these older iron furnaces, you'll find it looks like obsidian or black glass. It'll be bubbly. It'll range from black to gray to bluish green. It's really neat stuff. Now, here we have this nice illustration that shows, you know, how wood was covered, burning wood, smoldering wood, was layered and then covered, and then air holes put down through it so it continued to smolder until it was charcoal. So they called it roasting. So now we're going to walk up into the stock shed. As we get closer, you kind of get a feel for how tall it is. So, I almost missed it. So we believe that this may have been used for demonstration purposes, but this would have been a pit to show you what it looked like, you know, that was dug out, and then layers of wood were burnt and then covered up with soil, and then another layer of wood being burnt until it was compressed. And this is what it would look like. And after it was done burning out and the charcoal being formed, it would have been uncovered, and now you have your charcoal fuel for your charcoal furnace. Again, I'm just a tourist that likes to wander around, and only thing I really know about this is what I've heard from other people or read from interpretive signs. So if anybody has any corrections or additions or like, hey, you're wrongs, that's okay. Let me know. I'd prefer to be wrong and learn than be wrong and not know it. So what we have here is raw iron ore. There's no interpretive sign for it, but having seen iron ore before, this is what it is. And we kind of have an idea. Here's some good coloration on the end of it. So this is raw. I mean, this is as it would have been, you know, dug out. Kind of turn here, kind of get an idea for how immense this shed is. Reminds me of some old lumber mills you used to find. Now, this one caused us to get our engineer brains thinking. So we have raw iron ore, and now we have this, looks like an old washing machine, right? When you look up in close, we're like, okay, that looks like flint. And if we look down, we have a pintle. So this is big, this stays in place, and that moves on the inside. And here we have this, looks like a pulley system, kind of wide for a rope, so maybe a strap. So we're thinking, man, this is a lot like a washing machine. It also kind of reminds me of what you would see, maybe the same process as a cane mill or a sorghum mill. And here we have a chute, and I can't really get underneath here with the camera right now, but there's an opening there. And the thought is that maybe there was a trough here. So imagine, if you will, your raw iron ore being dropped down into this harder stone. Now the bottom of it is constantly moving, so it's grinding. And that grinding power is provided by this pulley, which most likely, manpower is a little bit much and steam power seems inefficient. So imagine if you had like a little corral out here with maybe a horse or a mule walking around in a circle. And as that circle spun, there would be another pulley on that end that drove a strap, which moved that pulley. So since the donkey or horse is making a large circle, and this is making a small circle, this would move at a mechanical advantage. It would move really fast. So you have this softer iron ore with its impurities being agitated inside of a harder stone. But that process would cause it to, become pulverized. So we'll pan around here and walk up this way. So given the amounts of iron that were created in a day, you think about the large numbers, and we'll see the numbers when we walk down into the charging house, of resources that were needed. You needed a lot of iron ore to create this refined or processed iron material that we have here. And it might show up on camera, it might not. It has a real red tinge to it, almost like a finely ground rust. So if you're trying to make something molten, it's easier to do it if it's a smaller material, right? So after it's ground down, it's in this fine material, it's more easily to be molten. So we have that pile here. So you'd be going through a lot of iron ore. The iron ore takes up a large amount of room. It gets crushed down. You have a donkey out there. He needs to eat, probably more than one team of donkeys or horses. You'd also have a large amount of coal. You got to keep this thing hot. If it cools off, then it's not going to have the same effect on the iron ore. It probably has to be heated at a certain temperature for a certain duration of time for that iron to be processed properly. So here we have, again, how charcoal is made. Get it nice and tight there. Here we have that, mounded structure. And you can see that charcoal, that wood, smoldering at high temperatures. And then you see as the earth is removed from it and the charcoal's raked away. So again, just showing the amount of resources that are needed. An ox team pulling approximately 100 bushels of charcoal. So a lot of charcoal means that there were a lot of trees, a lot of forests were cleared quickly. Now here's a drawing of loading of charcoal at Vesuvius furnace just down the road, and a picture of a charcoal pit at Olive Furnace in Lawrence County. So here we have the fuel, and behind us we have the pulverized ore that was used to create iron. So we'll walk down. This building is easily 50 yards across. Maybe 15, 25 yards wide. We don't know if this was a hands-on educational site where they were showing bricks. I don't know what the purpose of it was, but looks like it would have been a lot of fun. So if you guys are interested, you might want to check out Buckeye Furnace's website, see what learning opportunities they have. So we'll come down here before we walk into the charging house. And you've already seen the charging house from the front. And we started with it because we knew that's what most people would be familiar with, because for the most part, that's all that remains of these older iron furnaces. Now, the last ingredient that's used in iron processing is limestone. And in this area, not only is there a large amount of forest for making charcoal and a large amount of iron, but we also have large amounts of limestone. We see that from building materials to the creation of lime for fertilizers, but it was also used in the manufacturing of iron. And it was due to its difficulty of being transported, because these things could weigh tons and tons. Iron furnaces were usually constructed close to limestone. So there would be quarries locally, or even some of them were built right into limestone hillsides. Limestone was also used as a flux. Now, when you heated it in the furnace along with iron ore and charcoal, it combined with the impurities to form a hot mix, a hot pastry mass known as slag, which floated on the molten iron. So as it came off in troughs, that slag could be removed. And some places like Laurel Furnace down in Greenup County, Kentucky, you can find these immense mounds of slag that are still there, from the 1840s. So that's one of the things that we still have, is these piles of slag. So this is the part that I'm super excited to show everybody. Again, because, we don't see charging ramps anymore and charging houses. We don't see the inside machinations of how an iron furnace worked. We'll make our way carefully down the hillside. From the outside, we kind of notice, wooden structure, and we have this huge brick chimney. And then here on top, we have not just for ventilation, but for light. You think we take it for granted now that you would have had a lot. Well, we just have lights strung everywhere. And that wasn't so in, your 1840s to 1870s. Your daylight is what you had. Now, this is the bridge loft / charging house. And we've been provided with a nice illustration of how that works, and as well as a map to show where you are in relation to the other structures. So, you have the company store that we walked up the hill from, along with the scales. We have the coal shed that we just came down from, the engine house, and now we're at the charging house. Now, just to kind of give you an overview, this is where we're going to be walking into from this side. And when we started out, we were here at the furnace, and here's the casting house. Now, the furnace, if you've ever been to Vesuvius furnace or any of these other older charcoal furnaces, this is what you're most likely going to see, these stone structures. And all these other wooden structures and brick structures, have either burnt or been repurposed. So those are gone. So this is the interpretive sign for the bridge loft and charging house. And we'll walk in here. And I just want to say that this building has been either really well preserved, or it's been a great reconstruction. It's been well maintained. Entrance occupancy of 16. I think we're good here. So we'll let the camera adjust to the light. As you can see, it's really dark in here. So imagine getting up early in the morning and maybe the sunlight's not even reaching over the hillside yet, but you're already at work. And what little light you have is from these doors being open, or that's coming in from the roof. And maybe from the furnace itself. So here we have another sign to help us understand how this older technology worked. I'm just going to read it. It said, iron furnaces similar to Buckeye furnace in the Hanging Rock iron region were also referred to as blast furnaces. This term applied because air was compressed, blown or blasted into the crucible of a furnace, raising the temperature and thus speeding up the iron making process. So imagine like a blow dryer. In both methods, a small steam engine was employed that operated several blower tubs, or crude bellows that pushed the compressed air into the furnace's crucible. This engine received its power from steam-generating boilers at the top of the furnace that used spent furnace heat to convert water to steam. One method was called cold blast and the other hot blast. The cold blast method took outside air, compressed it, blew it into the furnace. This method was not as efficient as the hot blast method, but the iron produced by it was believed to be superior. The second method illustrated below was called hot blast. This method piped air under from the engine house into a large brick oven where it circulated through a series of iron pipes. As the air circulated, it was heated to about 600 degrees Fahrenheit by the gases in the furnace. The heated air was then piped to the base of the furnace and forced into the furnace's crucible where conversion of raw materials to molten iron was taking place. Now, the gases produced inside the furnace were forced through a channel beneath the boilers. Heat from these gases converted the water to steam, and that was used to power a small steam engine on the lower level. This engine drove the blower tubs that provided the compressed air needed to raise the temperature in the furnace. The iron master could vary the quality of the iron and the amount of fuel needed by regulating the temperature of the blast air. Hot air blast required less fuel but produced a lower grade of metal, while cold air blast produced a higher grade of iron and consumed more fuel. So let's see if we can kind of correlate what we're seeing in front of us. Now, this is this brick structure here, compressed air in from the engine house. So looks really small, but that's easily 10 foot across and extends all the way outside of the structure. Now, if we look here, we have steam pipe, and then we have these boilers, these iron boilers that run the length of the charging house. And then beneath that, these boilers, pipe containing hot gases from the furnace heat, the water in the boilers. And that pushed it down below into the furnace, or up from the furnace. Let's just walk here and kind of take a look at the structure. We have this hoist for moving material, a lot easier than shoveling it. And right now, if I could show you beneath, we're directly beneath the furnace itself. And from here, where we're on the boilers and directly over the furnace, we switch from being on wood plank to being on brick. And here we have the end of the boilers. And here we have, looks like a door, maybe for clean out. We look up, and there we have our boilers. We'll just kind of pan around here for a second and walk around the rest of the structure. So again, this is the charging house for Buckeye Furnace in Jackson County, Ohio. Don't know if I've said that yet, but just for those that are now joining us, I'm gonna walk around here, the edge of the building, just so you can see everything. And we're back where we started. Kind of give everybody a chance to look. And this is, I'd say, about half the size of the stock house that we were just in. And here we have the gabled roof. So good for letting light in, also good for letting heat out. So one of the advantages of the style of construction is it have a lot of ventilation. But, well, I'd like to thank you all for watching us today. Again, we are at Buckeye Furnace in Jackson County, Ohio, and encourage anybody that's in the area or just interested in early Ohio history or history in general that's in the area to stop by here. It's free of admission, and it's a great way to patronize our local museums. Thanks a lot.